1.6 is all about complex numbers. Complex numbers are essentially involving I. And I is an imaginary number that comes from the equation I squared equals -1. So, this is kind of the whole case behind imaginary numbers. And it essentially means that if there aren't zeros that you can see, there are probably zeros that are imaginary. I know it seems silly, and we'll get into this a lot more second semester and later on. Not really in calculus, actually, but later on in formal logic and real analysis and things like that. Um, so right now, a couple of things. Treat I just as a variable when we are doing a couple of things like combining like terms, foiling, factoring, combining like terms again with subtraction, all of those things. But the one thing you have to keep in mind is that I squared is -1. So essentially when you get an I squared, for example, right here, you treat it as -10 times essentially. There's a little mark there. -10 essentially times -1, right? So when you treat it like that. Lastly, because I squared is -1, we've got a couple of things that happen. Anything to the 0th power is simply 1. Anything to the first power is simply itself. In this case, we know that I squared is -1. And then finally, I to the third is I times I squared, which of course is -I. And then of course it repeats. So I to the fourth, I to the fifth, I to the sixth, I to the seventh, it goes on and repeats. So essentially I to the 23rd is simply following a pattern. And that's pretty much it with that. Here are a couple of notes that show some things on there. A couple of things similar to radicals. For some reason, we don't like i's being in the denominator, and when that happens, we're going to multiply by a conjugate, which is essentially 1 plus 2i if the original function is 1 minus 2i. And the reason we like doing this is because obviously, as you can see here, the middle two terms go away in your FOIL. It's the O and the I. The outside and inside terms go away. And then lastly, when you get your 4i squared, when you get your 4i squared here, that's simply a plus 4, right? So the bottom ends up being much more manageable, and for some reason mathematicians like that. And then lastly, solving equations. When you solve equations with the capabilities of solving for imaginary numbers, essentially what happens is you're using A, B, and C still, where A is 1, B is 4, and C is 5. If it doesn't factor, as this one does not, you're going to end up using quadratic formula. And when you do that, you get a negative root. And negative roots before, we just said that there are no real answers, and that's obviously true, but these are imaginary answers. So you're going to do it the exact same way with the sense that I squared is -1. So take the negative out to be I, and then we have a 2, of course. So in this case, that's that. It's not too bad once you understand just the fact that I squared is -1. And after that, everything's the same.